classifications and proportions is 5.6. So that means we're going to do word problems. Word problems that deal with proportions. So you know you're going to be setting up a proportion from the word problem. Okay? Alrighty. Here's a word problem that says, this is actually how they do this too. To determine the number of trout in a lake, a conservationist catches, okay, he catches, and I need to make this a little smaller so you can see what I'm writing. He catches 112 trout, tags them, and releases them. So in this big old lake, there's 112 trout that have tags on them, right? We don't know how many are in there, but they're trying to figure that out. Later, they catch 82 trout and 32 are tagged. Okay, I have learned, don't put catch over here. How many they caught is not a good number, a good thing to write here. So, instead of writing catch, because they caught this many and they tagged this many, right? So don't use the word catch. They tagged this many out of the total in the lake, right? And out of the total 82 that they caught, this many were tagged. So what do you think our labels should be here? Total and tagged. You can put either one on top or bottom, it doesn't matter. You can put how many tagged out of the total or the other way around, it doesn't matter. Okay, when they first caught the fish, they tagged 112 out of all of the fish in the lake, which is what we're trying to figure out. How many are there in there? Later, there was this many tagged out of a total of 82. So multiply and divide, and you'll see what they guessed about how many were in the lake. 287 what? Trout in the lake, right? Word problems, you always should put what it is that you found. Okay, let's do another one. Coffee beans. We haven't done this before, right? We didn't do 5, 6 yet. Okay, this just looks so familiar. We did something like it in 114 a couple of days ago, last week. Okay, coffee beans. Coffee beans from 14 trees. So the beans from this many trees makes 7.7 kilograms of coffee. Okay, this is the average amount that each person drinks in a year. Some people don't drink much, and I make up for it. I drink a lot. Some drink none, some none. I make up for it. Okay, so the beans from how many trees are required to produce 638 kilograms of coffee? So what would we label our proportion? What do we have here?
638.
The labels,
Oh,
the words.
Trees and kilograms.
Trees and kilograms of coffee, or trees and kilograms, you don't know. Okay, so 14 trees produces 7.7 kilograms. How many trees produce 638 kilograms? So what do you do to figure it out? Multiply, divide. How many?
68,776.4.
11, what? 60? Even? Okay. If it came out to 1159.9, you don't do .9 of a tree, do you? So you would have had to let trees, people, parking spaces, some things you just don't do a part of one. You know, you have to round up. It's good if it comes out even, if not, there's some things you instinctively know, oh, I'm not gonna have a .3 of a person. So if you need 11.3 people to do something, you're gonna need to go ahead and have that 12th person. Unless you can find a .3 of a person that could do something. And then looking at the label, you know that was trees that we were looking for.
And that should be 68.
1168?
No, 68776, so it should be 6878.
Are you sure? Do the numbers again.
I did it twice.
Because the book says 1160 and that's what they said it came out to.
Okay, yeah.
Maybe the last 7 didn't take or something.
I think it's how I put it in.
Okay, let's do. A rope is 28 feet long, and it says, how can the rope be cut so that the ratio of the two segments is a 3:5 ratio. It may not be even numbers. It may not be like 14, well, that may be, it may not be like 10, 18. It may be, you know, a fraction. So what do you think we could do to label? If you have two pieces of rope, one's going to be longer than the other, right? Well, this is short and long, right? If we want to put short to long. The short side to the long side, right? Short side's 3, long side is 5. What can we put here to make it add up to 28? Because these two have to add up to 28, don't they? How can we figure that one out? If we put an X, what do we put for the other one?
28.
28 plus X is 28? No? Philip, any ideas? Any ideas? How about if we put X and then
28.
28 what?
X. Minus X.
Minus X. If this was 2, you do 28 minus 2 to get the other, right? 2 and 26. Now, does that make sense? Okay. So how do we solve a proportion if we can't just multiply and divide? Cross products are what? Cross products are equal. Okay. So let me get another sheet of paper here. Move that one up. So if the cross products are equal, we have 5 times X equals 3 times that. Okay, what's 3 times 28?
84.
Okay. Minus 3x, right? We did that, and we did do that. Okay, so add 3x, solve for x. So we have 84 equals
2x. Oh, 8.
8x, right?
Yeah.
Divide that by 8, it's not going to be even, is it? Doesn't come out exact.
10 and a half.
Yeah, 10 and 4/8, which is 10 and a half. So if one of them is 10 and a half, what's the other one? This one is 10 and a half.
17.
The other one's 28 minus 10 and a half.
17 and a half.
So if you do it by hand, you have to borrow one and put 2 halves, right? So one is 10 and a half, the other is 17 and a half, and they will have a 3 to 5 ratio. If you multiply this by 5, oh, no, not multiply by 5. Huh. 3, probably multiply it by 3/5, huh? 5/3. I don't know. If you reduce it, that's what you could do. Put this over this as a fraction. If you reduce it, it'll be 3/5. You want to do it or no? You just believe me? Okay, we don't need to go probably reduce it. Okay. Let's do another one. A Boeing 747 flies 2420 miles. Okay? Here it is, right here. It flies 2420 miles with the wind. With the wind. Oh, this is
It's
fun.
lost with 230 passengers.
Yes, it does. It's lost. Ends up in the
In the Pacific.
in the same amount of time, it can fly less against the wind because the wind's dragging it back, right? The cruising speed in still air is 570 miles per hour. Find the speed of the wind. Yes? Come on in.
This is-
Oh, thank you. I'll share it with you guys.
Is it popcorn?
Yes.
Oh, I figured it.
Yes, it is. Good popcorn, too. I'll bring you guys some.
All right.
Thanks.
Bye.
We live down the road.
I'm gonna bring ice cream next time.
Okay. The 747 number we don't need, we need how far it went, right? It went 2420 with the wind, right? And it went 2140 against the wind. And the rate of the plane with no wind against it in still air, the rate of it is 570. That's what I got from all those words. Okay. If you have a boat going against current and with current, a plane going with wind and against the wind, things like that, when you have the current of water or wind helping you, something like that, you're going to have to add and subtract the current or the wind speed. Okay? When you're going to add the wind speed to your, how fast you're going, when would you add it to it? When you're going with the wind, right? Not against it, because it's helping you go faster. Okay? So if you're going with the wind, you're going to add the current. Against the wind, you're going to subtract the current. Okay, what we're trying to find is your current. Okay, so we'll probably use C, right? We're going to add the current and subtract the current. Okay, so we have this right here is with the wind. 24, oops, I can't write today. 20 is the distance. Remember, the distance is the rate times the time, isn't it? The rate, we don't know. Yeah, we do. We do know the rate. The rate is going to be this plus the current, right? That's our rate times our time. The other one, 2140, is the rate minus the current times the time. Right? Didn't it say something about it went this far with the wind and the same time that it went this far against the wind? So it's telling me the time is the same, right? Time is equal to the time. If you were going to solve distance equals rate times time, if you were going to solve that for t, what would you do? What do you do to solve for t right here? Divide by r. So time is distance over rate, isn't it? Okay? Instead of having to write all this, you could actually put distance over rate equals distance over rate. And we need to label one of them with and one of them against. This is with the wind, and this is against the wind. Or you could do it the other way around. It doesn't really matter. You've learned in proportions, it doesn't matter as long as you have it marked, right? The distance with the wind was 2420, wasn't it? And the rate, what did we say the rate was? 570 plus the current. Okay, the distance against the wind, 2140, the rate is 570 minus the current. How can we solve that? Cross products are what? Equal. Cross products are equal. That times that will equal that times that. It's going to take a little bit of paper, so I'm going to grab another one. Okay, so we have 2140 times that. 570 plus the current is equal, cross products are equal to that times 570 minus the current. Okay? I need some calculators going here. 2140 times 570 is what? Two people do it to make sure we don't make mistakes.
1219800.
Yeah.
No. So 1,219,800? Okay, two people got that, so we know it's right. And then we need 2420 times 570.
1,379,400.
Yes?
Yes.
Okay. Minus 2420C. Okay. What side do we want to put C on? Do we want to add this or subtract that? We want to add this, right? That we have two positives. Plus 2420C. Okay, we're taking that over here, so at the same time, why don't we take this to the other side? Subtract 1,219,800. so that'll go away. Minus 1, 219, 800. Now make it quicker, right? So this added
4560.
and this subtracted 159,600, okay, divide that by 4560. So our current is 35. And it said our speed was 570 miles per hour. This 570 actually was miles per hour. So we used that to know what the unit, the 35 is in miles per hour. So we have a 35 miles per hour wind, okay? Let's do a river. Or, yeah, we have a river. We could do a river. We could do, there's one that has a treadmill that's moving. And walking with the treadmill and walking against the treadmill. Would you rather do a river or a treadmill? We don't have time to do a lot today because we got 3 sections. The river? Okay, let's do the river. We're getting into the ocean. Water sports. Okay, the current in the Animas River, wherever that is. Anybody know where the Animas River is? I've heard of it. I don't know where it is either. Okay, and the current in the Animas River moves at a rate of 4 miles per hour. That's the current. Okay, Sydney's dinghy, D-I-N-G-H-Y, it's a little boat. I don't know what it looks like, but I know a dinghy's a little boat. Okay. It will Sydney's dinghy, motor 6 you have to pick over 6 miles upstream in the same time that it takes the motor 12 miles downstream. Okay? What's the speed in still water?
You could have switched it to boat.
I could have just said boat and we wouldn't know it said that. Okay. Okay, it said the same time again. Okay, so we know time equals time. It said that the boat went 6 miles upstream in the same time it went 12 miles downstream. But I need to zoom out. Okay. Okay, so we need to say one's up and one's down. Upstream, downstream. What is time equal to?
Distance over rate.
Is distance over rate, right. So this will be distance, rate, and this will be distance, rate. The distance upstream was 6 miles. The distance downstream was 12 miles. The rate of the boat will be what? Going upstream. You're going against the current, aren't you? If you're going upstream, you're fighting the current, so you need to subtract the current. Going downstream, you add the current. Cross products are what? Cross products are equal. There we go. It's like you went to sleep. That's equal to that. Okay, distribute. Okay. We distributed, got rid of our parentheses. And what side we want the R? We'll subtract 12 or subtract 6? Simpler to subtract 6, right? And if we're taking this, we want to take the number over here, so opposite of minus is plus. 12 minus 6 is 6. 6R, 24 plus 48, 72. Divide by 6. 12 what?
Miles per hour.
Yep. The rate of the boat's 12 miles per hour. Okay? Any questions? I think I've covered all the things you'll have to do as far as word problems, so hopefully it's all covered.